Welcome to the Blind Tinkerer's Workshop. Good morning. Well, one of my viewers, first name is Bob, I had talked to him about a week and a half ago on the phone, and he had this record player he would like me to go over. It's not working, so he'd like me to fix it for him. And it's a Voice of Music. It has two satellite speakers and a single speaker in here. And I'm going to go over it now to see what's wrong with it. He replaced the cartridge in it already. He got this on eBay. And as you can see, as small as this thing is, it takes up the whole bench just about. But anyways, that's what we're going to do today. We're going to go over it. And he gave me the book, the original owner's manual on it here. I believe it's a VM 309, if I'm not mistaken. And we're going to look at the schematic here. It uses two 50 EH5 audio output tubes and one, I think it's 112AX7, or perhaps two, I'm not sure. I think it looks like it uses just one. Yeah, okay. So 12AX7 is a twin triode. So one half is driving the right channel, one half is driving the left channel. A lot of the capacitors in this is ceramic discs, which you usually do not have to replace. They're almost always good. The electrolytics will probably have to be, but what we're going to do first of all is we're going to set this up so I can see what's going on here. And hopefully you can see me all right, because I can't see the back of the camera viewfinder, so I'm kind of guessing if I'm in camera, maybe at least the record player's in camera. If I'm not, it don't matter if my ugly kisser's in there or not. All right, it's a VM model 309. I hope you can see that. And the camera mount, you know, this camera mount is good, but you got to stop. It's got to wait for it to stop doing its little movement here. Anyways, I got it open, and he had already taken the cover off, and he also put on a record. Oh. We'll have to put that somewhere so it don't get damaged here. Don't have a lot of room in this little shop here. You can't have everything, folks, you know. All right, this cover, I guess, don't come off. A lot of times they unhinge or slide one way or the other, but I guess it don't come off, so we'll have to work with it on here. Now we got to remove the record changer. He tried to work on it, I guess, but the first thing we're going to do before we do anything is we're going to plug it in. Now there's one speaker here, and there's two satellite speakers like these, which have a little 2-pin plug. So I decided to take these also, because I don't have plugs that will go in to make connection to the speakers that I've got here. So they don't take up much room anyways. First thing we're going to do is to put on the variac, the isolation transformer on. I don't have my DIN bulb tester built yet. So what we'll do is we'll turn this down. We'll turn the variac down to 35 volts. Of course, the pilot light's not even on here because it's only getting 35 volts here. And we'll turn the record player on, so we got to turn it on through the turntable. And now we'll bring up the voltage. And the turntable's turning at 62 volts. Bring it up to 80 volts. We turn the volumes up all the way. This is the volume, this is the tone. There's only two controls on this. Now he had this running, but he couldn't get any audio out of it. He can just barely hear a little tiny sound coming out of the speakers. So obviously he ran this, you know, without the bringing up the voltage slowly, which is all right, I guess. So it shows that there's no short in the electrolytics. We got it on 100 volts now. I assume I'm still recording. Yep, light's still blinking. All right, we'll bring it up to 115. Exactly 115. Nothing. Now, you should still hear something. There's only one speaker here, which is the bass speaker, and there should be two satellite speakers that I should be plugging in. These hinge pivot points here, the way they designed this, and I've never seen a design like this, is on these pins here, there is a speaker connection on these hinges. That's kind of a weird way to do things. And the schematic shows that when the speakers are unhinged, you use the cord that's in here and you plug them in. But however, if they are hinged, in other words, the speakers are on like this, these are the connections. The speaker's supposed to be connected electrically through the hinges. In the back here, I can't show you right now, there are two wires connected, one to each hinge on each side. I would think that would make an awful staticky connection, relying on the hinges to do that, but that's the first time I've ever seen that. However, if you take the speakers and detach them separately from the phonograph, then you use the wire which you pull out here to make your connections. All right, and that's what it shows on the schematic right here. Okay, so this is the original owner's manual that Bob got from a place that has original manuals for things like this. This is the model VM309. So, anyways, we're not going to deal with that right at the moment, because I'll tell you, first thing we're going to do is we're going to test the tubes. I have a B&K 606 tube tester that was given to me by one of my viewers a while back. And I'm going to test the 4 tubes that are in this. So we're going to remove this off the bench and I'm going to remove the tubes first. Take this and set this on the floor because I'm very limited. I can't push it onto the side because I don't have any room in this place. So that's the first thing I'm going to do, is to test the tubes. So let's take one step at a time here. Let's get this off the bench and we'll get this tested. And we'll come back when I get the tester set up here. All right, looking up a 50 EH5 here in the book. So 50 EH5. I'm going to have to get my magnifier out now. Where is it? Okay, 50 on the filament. All right, 15 to 125, 30, 38, 39 to 50. 39 to 50. Alright, that's a setting for that. Alright, well, 50 volts, A is 30. A B is 2, is B. Okay. And C is 5, right here. And socket 1. All right. Always set your numbers, your dials first before inserting the tube, and always make sure that you start at the lowest filament setting on any tube. In this case, we're set to 39 to 50 because that's what this tester filament range is, and it's just a 50 volt filament. A quick tip on tubes. I've heard people say, like a 12AU7, they say 12 AU7. The first number is the filament voltage, so you don't say 12 AU7. It's 12 AU7, AT7, AV, whatever it is. The first numbers are the filament voltage. Just remember that on the vacuum tube. A 12AU7 has a 12 volt filament. A 6AU6 has a 6 volt filament. On your 12 volt tubes, there is a tap on it so you can parallel the two halves of the filament because it's divided in the middle, and you can run it on 6 volts. Alright, so we're going into socket 1, which is over here. Alright, and we'll let it warm up. There's a short indicator right here. No shorts. But I think there is a rotation. Yeah, here it is. Rotate for shorts. So here's C. This is the one you rotate for shorts. So what I'm going to do is to cover up so I can see this. A short indicator should flash as you rotate. That's normal. If it flickers when you stop at any one position, you've got a leakage in the tube. Absolutely no shorts. I'm going right around. So we got to remember to put C back on 2. Goes back on to 5. Okay. Alright, so we got no shorts. Make sure I'm still recording. Yeah. Alright, so now we push the quality. Okay. This is not a mutual conductance tube tester, but it's a very, very good tester. I got this from Don a while back. And the only thing I have to do is I still got to buy some deoxit. The octal socket needs to be cleaned. And I got to use some deoxit because when I test an octal tube like a 6X5, I have to hold it over, otherwise the meter goes to 0. And I bought a set of little brushes, real thin little brushes from Harbor Freight. They come on a little ring and about 4 or 5 little brushes. And they're real tiny. They can get right down into the pins. And I'm going to clean the pins when I get some deoxit. I got to get some. I keep putting it off. Okay, so that 50 EH5 is good as far as emissions concerned. We're going to test the next 50 EH5 now, so we're going to leave the settings the way they are. We'll pull this out and we'll get the next 50 EH5 because there's one for each channel. We'll let that warm up. Alright, so we're going to do the same thing. We're going to rotate for shorts, stopping back at 5. I've got to remember that so I don't have to look back in the book. Okay. If in doubt, always stop like this and look. No shorts. Back on 5. Check the quality. Quality, I should say. Alright, that one reads a little under 100. Remember, this is not a mutual conductance tester, but it reads very good. Now, this also has a scale for grid emission. When your grid gets contaminated, your control grid gets contaminated, it can emit electrons. So this tester can check for grid emission, and it's done right here. Alright. We didn't do that on the other one. Like I say, I've only used this tester one time to test the 6X5 and one other tube. So let's go back to the other one and check the grid emission on this one. We'll let that heat back up and we're going to check the grid emission. We already checked for shorts. And we got to remember we're going back to a 12A X7 now. This filament must be brought down or you're going to have a blown tube. So whenever you put your tube tester away, always turn the filament voltage control down to the lowest point so that you don't inadvertently blow a tube out, especially if you are testing 1-volt tubes, which this will do. But on the newer tubes. Alright, so let's check quality. Okay. We're up a little closer to 100 on the quality, and the other one was down a little bit. Let's check grid emission. Nothing. If you got any reading of grid emission beyond the green here, I don't know if you can see that, but you probably can't see it. As long as it's down like a 1/4 inch at the bottom scale, there's a little green area right there. If your needle moves but not above the about a 1/4 inch of that green, it stays in the green, you're okay. You only got a little grid emission. I used to have a Sencor tube tester. I kicked myself for getting rid of that too. I can't remember what model it was offhand, but it had a grid emission and it had a very good leakage test too. So this is every bit as good as that. Great little tester. I love this thing. And it has the original book. Okay, so no grid emission and quality is very good. So this tube is good. Now we're going to test the 12AX7. We're going down to 11 to 14 volts. Always, always make sure your filament's the most important. You don't want to destroy a good tube. Now, a 12AX7 is a twin triode, high gain twin triode. And triode would have a plate, a grid, a cathode, and of course a heater or the filament. So you got two sections, two tests to make on this, two halves. Well, we'll come back on this as soon as I get my, I look up the 12AX7 because I don't want these videos to become any longer than they need to be. Alright, 12AX7 is, as I said, a twin triode. It's right here. So 12 volts in the filament. .42 on the shunt. 10 on B. 2 on C. And socket 2. Which is right here. Again, always check your filament voltage on... damn thing's moving again. I don't want to get you people sick out there. There's nothing worse than a damn shaky video. I've seen so many of them on YouTube, I just click off of them, and I don't want mine to be that way. Alright, come on, Ben, old goat. Find the damn hole, will ya? Pretty bad when you can't even find the damn tube hole. Can't find the pinhole. Alright. Okay, so this is test number 1. We'll let this warm up. On test number 2, the only difference is C switch here is on 7. No other changes are made here. The A control, in other words the shunt, on some testers it's called a shunt. This just says A. Or some testers it's called the load control. Is on 42. We're double checking the readings here. This is on number 10, and this is on 2. So let's check for shorts. That's the first thing we're going to do. And again, I got to shade this so I can see it. All right, no shorts, no grid emission. They really should, you know, always check your grid emission before the quality test. I should practice what I preach. Okay, she's up there in the middle of the green on a 100%. Again, no grid emission. Now we go to the second. You don't need to rotate the shorts because no other elements of the tube here are changed other than this. So we've already stepped through the cycle here, so you don't really need to go through the same thing because the only switch we're changing for the second part of this triode is C. And we are going to be going to position 7, which is right here. Okay? No grid emission, 100% on the quality test. Okay, so Bob, all your tubes test good. So, okay, so we are going to turn off the tube tester. When you shut down any tube tester, regardless of what model you have, this one does not have an on and off switch. You just unplug it. Turn your heater down. All the way down to the bottom. This one rotates right around, so you can, you can go right up to 50 volts. Most testers, the older ones, would go like 117 volts because some of your real old tubes had 117 volt filaments. Some of your old rectifier tubes, 117 Z7 or Z3, I can't recall the number now, going back 50 years in memory, and the memory gets faded. So always keep your voltage down real low, 1-2 volts in this case. And unplug it, and we'll join you when I get this thing back up on the bench. The hardest part about this is getting that changer out of here. It didn't want to come out. Good thing he had the instructions to get this out. And there's only two plugs, your power plug and your left and right channel. So the changer comes right out. So we'll set that aside, and we better put this down in a good safe place here. Hang on a minute. Well, looks like he had some mice damage in here. I mean, not damage, but we had some mice in here. Mouse turds. Nothing major. There's no, I shouldn't say mouse damage, but I don't know what's under the chassis. We got to get that out. It's raining out. If you're hearing noise outside here, you're hearing some noise. It has been raining today. It's a cold rain. It was snow this morning. Had to clean off the cars. About an inch or so, maybe a little less. You've got an electrolytic here, which no doubt will have to be replaced. And there's only 3 tubes in here, which I've taken out. And what appears to be could be a 6x9 speaker in the front here. It's either a 6x9 or a 5x7. So we're going to commence to disassemble this off camera here. And when I get the chassis up on the bench, I can go over it. Alright, I got the amp. What a job. The instructions tell you to just loosen the 4 bolts underneath, take the knobs off, slide the amp out from underneath. But I had to remove these things, which they didn't mention, in order for it to clear this board right here. There wasn't enough room. I hope that's not asbestos, some kind of weight material in there. I wouldn't think it would be, because there's no flame or anything or any high heat involved there. These just are shielded. This is like a cardboard, but it's got this material inside. Anyways, these are just the volume control and tone control and so forth. So that acts as a shield. They don't even show these in the pictorial diagram on the manual. It shows you the parts right here, sitting here. So it doesn't show you these at all, but these were held in with these little tiny plastic things that you snap down into the chassis right here. So anyways, I'm in the process of pulling this right out of the cabinet here and then try to get this cleaned out. Alright, I brought the cabinet outside, and all it required was a brushing and blowing out the mouse droppings, just a little bit in there and some dust, but there wasn't all that bad. Here under the chassis we have a lot of ceramic discs, which are not really something we have to worry about. If I can show you there. We're going to test. I'm going to test these resistors. A sand resistor here. This is probably a fusible resistor. This uses a silicon diode. I think it's a 300 or 500 milliamp current rated diode. It's possible it could be gone. There's an electrolytic here we're going to change. This main filter cap right here, we're going to either remove or leave it in and add a terminal strip underneath it, which you got to do anyways. We can't use these connections here. But we want to keep the wiring, obviously, for high voltage underneath here. We don't want to put any terminal strip on the top of the chassis. Chassis is relatively thin, and temporarily I stuck this back on. These are shields here for hum, just to so I don't pick up any interference and stuff. And I don't think they're asbestos. I wouldn't imagine that there would be. There's aluminum on the aluminum coat. It's like aluminum foil almost, but there's white stuff underneath. Looks almost like asbestos, but I doubt it. This was made in 1960, and I think they did away with asbestos by then. Here's your audio output transformers. Of course, it's only the 50EH5 puts out a max of 3.8 watts. So it's sufficient for this type of unit. This is the molded cap. I think it's a 0.1. We're going to change that, even though it's a sealed cap. It's not a wax paper, but nevertheless, inside they're probably wax paper. So it's almost like the Black Beauties. The Black Beauties look like this, only they got all these colored stripes on them for the color code. And those are very bad capacitors. You should replace them. These are ceramic discs here, and the ceramic discs almost never go bad. They do occasionally, but you know. So we're going to go through the circuit here. We'll do that off camera.